Hello everyone, my name is Tigran Tran and this is my video for assignment 1. I'll go through each question and briefly explain what the code does. So let's start from the question 1. As you can see, I imported all the libraries into my assignment. So in question 1, I printed the shape of train images, train labels, test images, and test labels. So we see train images is 60,000 by 28 by 28, 60,000 images, each 27 by 27 pixels. Labels are one-dimensional arrays of 60,000 and 10,000. So for question 2, I use len on train labels and test labels. So we get 60,000 of training and 10,000 for test. One label per image. Question 3, I print the first 20 train labels and first 20 test labels. These are integers 0 to 9, each number meaning one of the 10 fashion classes. So let's move to the question 4. As it's a digital content, I print train images 5. The raw pixel matrix for the fifth training image. It's 28 by 28 grid of numbers from 0 to 255. And in question 5, I use matplotlib PLT_ImShow with the gray color map to display that same image so we can see the clothing item. As you can see here, it's our outputs. And so in question 6, I get the label with train labels 5 and use the class names list to see what it means. For example, 0 is a t-shirt top, and 1 is a trouser, and so on. So we both, so as you can see, both the number and the class name. Okay, let's move to the question 8. It's same as 4, but for the test set. I print test images 500 and the 28 by 28 pixel matrix for the 500 test images. For question 8, I plot the test image with PLT_ImShow so we can see what the 500 test sample looks like. And for question 9, I take test labels 500 and look it up in class names to get the class name again, the number and what it means. Here it is, it's pullover. For question 10, I do from TensorFlow Keras input models and layers. That gives us sequential and the layer types we need to build the network. And for question 11, I create my network as a sequential model. So we have one model object that we will add layers to next. Question 12, I add a flattened layer with input shape 28 by 28 that turns each image from 28 by 28 grid into a single vector of 784 values, one input per pixel. So talking about question 13, before feeding the model, I divide the pixel values by 255. So values go from 0 to 255 to 0 to 1, which helps the network train better. For question 14, I add a dense layer with 512 units and ReLU activation. So we have 512 neurons that take the 784 inputs and apply ReLU for non-linearity. I add another dense layer with 128 units and ReLU, so the network goes from 512 to 128 neurons before the output. And in question 16, I add a dense layer with 10 units and softmax, so we get 10 outputs, 1 per class. Softmax turns them into probabilities that sum to 1. In the video, I also explain that we use softmax because we need a probability per class. Under the hood, it's exponentiate to each output, then divided by the sum of all exponentials, so the largest score gets the highest probability. So in question 19, I need to answer the question, how do you compare fashion MNIST with what we learned using MNIST? I think that same format as MNIST 28 by 28, 10 classes, 60,000 train and 10,000 test. But here's the images are clothing, no digits. Fashion MNIST is harder, so accuracy is usually lower than on MNIST. That's expected. And question 20. So what can we infer from the difference in accuracy? Option A versus option B, but what could be the reason? In my opinion, option B and option A can give slightly different accuracy because the optimizers Adam versus Hermes prop and the lost forms are different, so small differences are normal. If one does a bit better, it's often due to the optimizer or loss fitting this problem a bit better. So in question 28, I use the models evaluate methods on the test images and labels that returns test loss and test accuracy, how well it does on unseen data. To check overfitting, I compare the last epoch's training accuracy with test accuracy. If train is much higher than test, the model is overfitting. In my runs, they were close, so overfitting was not strong. Evaluate gives us the numbers to discard that. Okay, thank you for your attention, and that's all for my assignment one. Goodbye.